Okay, for today, it's about quadratics. We started a new unit on quadratics, and I'm going to just review, because it's been, I guarantee you, at least 3 days since you've heard this stuff. When I said that this was a quadratic in vertex form, do you remember you could just get the vertex like boom? And it's not negative 3 comma 4. What is it? Come on, say it. 3 comma 4. Remember how this works? If you wanted, you could make an XY chart, couldn't you? And what would be the best number to put in? 3, because it makes the thing equal 0 at the beginning. And then that makes it easy to find the answer, which would be 4. Get how 3 comma 4 is an important spot? And in fact, it's really important. It's called the vertex. All right, thing number 2 that I taught you. I did teach you about vertexes, didn't we talk about these on Friday or Thursday? Okay. All right. Then I said there's this dotted line that runs down the middle of all parabolas, and it's called the something of something. Say it louder. I heard it. Axis of symmetry. Yes, it's the axis of symmetry. And some kids call it the axis of symmetry because it's x equals whatever this number is. X equals 3. You get how it's not just a point, it's a whole bunch of points that run right down the middle of the parabola. Does that make sense to you? All right, that's the axis of symmetry. You learned that one before. All right, well, another thing that I taught you is that there's a really cool little formula that's the beginning and the end of the quadratic formula. See if you can recite it. Research shows if I make you struggle to remember this little formula, that it'll stick better when I tell you. Don't say it. Let people struggle with it for a second. What is that little formula that tells you this axis of symmetry from using A, B, and C? Negative B, O, plus or minus square root of B squared minus 4AC all over 2A. And that's the formula. Notice it's the beginning and the end of the quadratic formula. That little formula tells you the axis of symmetry, and it's the x of the vertex. Do you get that if you know the x of the vertex, you could just stick it in and figure out what the y is? It's really handy to know what the x of the vertex is. All right, the next thing I taught you was this spot is called the something something. What is that spot called? The y-intercept. And I tried to make you memorize something, that the y-intercept is where x is 0. So if I give you an equation, you should be able to tell me a bunch of things, including the y-intercept. So you just stick in x is 0. Can you do that in your head quick? I can. As long as I can do 4 squared without a calculator, it's not that hard. 16 plus 5, did you get 21? Do you get 0 comma 21 is where x is 0 and y is 21, and it's called something special. It's the what? Y-intercept. The y-intercept is where x is 0. And conversely, the x-intercept would be where what? Y equals 0. The x-intercept would be where y is 0. Do you get I didn't do that here? I made x 0. What if I make y 0? Well, then you'd have to solve an equation. But let's just look at that for a second. If I put 0 in front, I had an equation. Let's say it's y equals x minus 1 squared plus, no, not plus 1. Let's make it minus 1. Then if I wanted the x-intercept, I'd set y equal to 0. Everybody do that. Put a 0 here. But the pain in the butt part is that this isn't factored. And if you can factor it, you should. So how the heck do you get it so you can factor it? All you have to do is multiply it out, and that's the new thing for today, is you take this, you have to multiply it all out, and then you'll have a different form. This is called vertex form, because a child of age 6 could be taught to take this number and this number, 1 comma negative 1. What? You didn't copy them exactly. No, I don't trust the inside. That's the vertex. That's easy, right? Tell me that's easy. Finding the vertex, super easy, isn't it? Okay, good. Finding the axis of symmetry, also easy. X equals what? 1. You just take the x of the vertex. That's the axis of symmetry. Super easy. But this next part, not super easy. Multiply this all the way out, everybody. And when you do that, you will get standard form. Now, some kids are just going to think, oh, I'm just going to square this and I'm going to square that. And you're going to get it wrong, because that's not how that works. Multiply it all the way out carefully, and then you'll have standard form. And that's the whole thing for today, is just taking equations, multiplying them all the way out, and then you got standard form, which is really handy, because then you'll know A and B and C. Know what I mean? Like right now, if I look at this, I'm a math teacher, and I can't tell you what A, B, and C are. So I can't use the quadratic formula on it. I can't do that negative b over 2a thing on it, because I don't know what A, B, and C are. But once I multiply it out, then. All right. So go ahead and do that. And then the reason we did it is so that then it would factor, because if you can factor it, you should. And so you should be able to tell me the x-intercepts, which hint has to do with the factoring thing, the y-intercept, which is where x equals 0, and you should be able to tell me the vertex, which should be like super easy, and then the axis of symmetry, which again, once you have the vertex, oh my gosh, so easy. Try to answer those 4 things. X-intercepts, y-intercepts, the vertex, and the axis. All if you can just multiply this out. All right, when you're done, compare with the kid next to you on those 4 answers. X-intercept, y-intercepts. Sometimes there's 2 x-intercepts, but hint, there's never 2 y-intercepts, or it wouldn't pass the vertical line test. Think about it. There can't be 2 y-intercepts, but there can be 2 x-intercepts. All right, get those 4 answers. I'll pause while you work on it. Okay, let's see how you did. First of all, did you know that you were supposed to break this up into an x minus 1 and another x minus 1 and then subtract 1? And then, did you know that that comes out to x squared minus 2x, and then there would be a plus 1 from these two, but then you subtract 1, which makes it, there's nothing at the end. So you could say plus 0, that's not illegal, but like that's your equation. That's called standard form. So then do you get that A is 1, B is negative 2, and you could say that there is no C, but that's kind of wrong. The C is just 0. So you do have an A and a B and a C. The C is just 0. Okay, so then we want the x-intercept. We set y equal to 0. That's right here. And then if you can factor it, you should. And some kids think, oh, it's weird, so it won't factor. No, this will factor. X squared minus 2x will factor. What's the thing that's in common in both of them? X. And then I'm left with what? X minus 2. Okay, good. I'm ready to help you in just a second. Go ahead and hit yes. For future reference, don't do it during the lesson. I can tell you're desperate, though. So, all right, here we go. The y. Wait a minute. The x-intercepts, I didn't do them. I just factored it. But then to actually do it, Mr. Patel, what are the 2 x-intercepts? 0 and 2. Those are the 2 x-intercepts. Now, if I was going to do an x-intercept, I'd make y equal to 0. So 0 comma 0. And the other one is 2. And so if it's an x-intercept, y is 0. So 2 comma 0. 0 comma 0, 2 comma 0. All right. The y-intercept, it's easier. The y-intercept is where x is 0. So I'm going to take this equation, y equals x squared minus 2x. And I'm going to go, x is 0. So there's 0 and 0. And I totally get some kid thinking that there was no y-intercept. But that's wrong. What's the y-intercept? 0. Y equals 0. It doesn't equal nothing. It equals 0. So it has a y-intercept of 0. All right. So if I'm making a y-intercept, it's x is 0 automatically. So 0, 0. That makes sense to me. It's an x-intercept. We knew it went through 0, 0 already, so of course it's a y-intercept. All right, and last but not least, we have the vertex. I could have got the vertex in minute 1 by just looking here. 1 comma negative 1 was the vertex. And the axis of symmetry comes from that. X, it's the axis of symmetry. X equals 1. There's your 4 answers. Did any of you have them all? All right, that's only 3 people that had them all. All right. So we're going to do that again because that's the whole thing for today. And now you saw me do it. You should have learned how to do it from that. And so here we go. Here's another equation in vertex form. Y equals x minus 2, quantity squared, minus 1. Would you please figure out the x-intercept, the y-intercept, the vertex, and the axis of symmetry? I'm going to pause. We give that a shot. Tell me how you started this one, Mr. D.
For the x-intercept, I set y to 0.
Okay, but you really had to kind of multiply this out, didn't you?
Yeah.
Okay, so let's do that. I agree, the x-intercept, you set y 0, but let's do this part first. So tell me what you got when you did this.
X squared minus 4x plus 4.
But then the plus 4 went with the minus 1, because these two make it plus 4. You're not wrong. But put the plus 4 with the minus 1, and you get? Good. And now, can that be factored?
Yeah.
Because if you can factor it, you should. It can. If you haven't already, everybody take a second and factor that. Did you guys get the factors? Mr. Long, did you get the factors for this one? Oh, wait. Brady?
Me?
Yes.
Uh,
Did you factor it or not?
no.
Okay, work on that right now. Everybody work on factoring that because that'll help you find the x-intercepts. The y-intercept's super easy. The y-intercept is set x equals 0. The vertex, super easy. It's in vertex form in the first place, so the vertex is just there and there. All right, I'm going to pause for a sec while you finish this one off. All right, you ready? You should have said x and x. What did you say, Brady?
I said x plus 4 and x minus 1.
All right, you were close, but yours comes out to positive 4x and negative 1x, and that makes positive 3x. That didn't work. And thank you for trying, but do you get these two numbers here that I've just erased have to multiply to 3? So Brady, what multiplies 3? Not too many things.
3 and 1.
It's got to be a 3 and a 1 then.
So it would be x minus 1 and x minus 3.
There we go. Notice he changed them both to minuses. In my opinion, that's what you should do first, is realize this has to be two negatives to make that positive. And to make that negative, it had to be two minuses. And then 3 times 1 makes 3. So then my final answer is negative 3x, and negative 1 makes negative 4x. Sweet. It's factored. Alex, now that it's factored, can you tell me the two things that we get out of that?
So x-intercept and y-intercept.
Okay, so how about the two x-intercepts are that one and that one, so they are?
3 and 1.
Yes, 3 and 1. And now, if I was going to make them into x-intercepts, I'd set y equal to 0, though. So I'm going to say 3 comma 0 and 1 comma 0. Those are your x-intercepts. That goes right there. Now, the y-intercept is much easier found right here. This is called standard form. Do you guys remember that the y-intercept is where x is 0, which would just zero out the first two numbers, and then it's just y equals 3? See how it's right there? So the y-intercept is 3. Should I just write a 3 here? No, it's the y-intercept, so x is 0. 0 comma 3. The vertex, it was just sitting right there. But not negative 2, negative 1. 2 comma 1. And the axis of symmetry. It's the axis of symmetry. X equals 2. Now, I'm guessing we got up to over half the class, but you tell me, how many of you had those? Raise your hand if you did. All right, we're only at about half the class. Now, is there any of these that you think are wrong? Maybe I just copied something wrong. Maybe I did something wrong. Tell me if you think something wrong. Yes?
Is the vertex 2 negative 1?
Is the vertex really 2 negative 1? Yes, it is. Did I? Oh, I didn't put negative, thank you. I think I said it, but I didn't write it. You don't trust this, so you use 2, but you do trust this. 2 negative 1 is correct, and you're right, there was a negative missing. All right, is there any other things that you think are wrong with my answers? Please tell me if you think there is. All right, then one last one, okay? What happens if I put a negative in front? Everybody write this down. Negative in front of x minus 3 squared, and then plus 1. Just in the big picture for a second, that was a parabola, wasn't it? Is it still a parabola? Yeah, it's just the negative made it do what? Flip. Upside down. Would you please sketch this parabola? Just sketch what you know it looks like. You know it's a parabola. You know it's been moved. You know it's been flipped. If, in my opinion, I would probably flip it first. You could move it to the right first. That's legal. But I would probably flip it first. And then I'd move it to the right. And then I'd move it up. Parabola normal. Parabola flipped. Parabola flipped and moved to the right. Parabola flipped and moved to the right and moved up 1. Final answer is like the yellow one. Now look at it. Does it have x-intercepts? For sure. Does it have a vertex? For sure. Let's see if the vertex comes out the way you'd expect. I expected the vertex to be 3, 1. Is the vertex at 3, 1? Yeah, looks like 3, 1 to me. It's over and up. Okay, so just because there's a negative out front, the only thing that's different is now you have what's called a maximum. Do you get if the top is the highest point, then that's a maximum? The red one has a minimum. If you have this parabola, I know it's right side up because there's no negative in front. As soon as I put a negative in there, better not put it by the equals. Make it red and put it here. Then this is an upside down parabola and it has a maximum. The other one, it's a normal parabola. So if I don't even know where it is, but I know it has a y-intercept of 6, but so maybe it's something like that. I know it's got a minimum though, because it's got a low spot because it's a normal parabola. How about when I put a negative here? How about now? Normal parabola? No. It's flipped, so then it would have a maximum. You getting the difference? Normal parabolas have a minimum or a maximum? Normal parabolas have a minimum. That's a normal parabola. As soon as I put a negative here, do you get this thing would flip upside down and it doesn't have a low spot anymore. It's only got a high spot. So I give you a really simple way to write it. For those of you that, if you're still struggling with it, write this. If it's positive here, it'll have a minimum. If there's a negative there, this one has, what am I to write? Come on. What's the word I'm going to write? Max. All right, cool. So, typical question for today gives you an equation, and then it'll say things like, what's the x-intercept? What's the y-intercept? What's the vertex? So, one thing you don't know how to do yet is to take something like this and say what its vertex is. I haven't taught you that yet. You can't do that. What you could do is factor it, and that would tell you the x-intercepts. You could also figure out the y-intercept, which is where x is 0. That's super quick. It's just -7, boom, done. But you can't find the vertex yet. That's the one thing I haven't taught you, and I'll teach you that on a different day. So if I give you this equation, let's see who's got a short-term memory and who doesn't. Does this have a minimum or a maximum? It has a maximum. because it's a flipped upside down parabola because of that. So it has to be like this. It has a maximum. What is the maximum? It'll be at the vertex. But Mr. Server, this one doesn't look like the other ones. Why doesn't it look like the other ones? Well, if I put the squared here, it's just the same. I can see how you might be concerned about that. But I'm just going to say, new problem. I'm going to put like a -1 here. Now do you see where the vertex would have been? But there was no -1, Mr. Server, so that the other one didn't have a vertex. Sure, it has a vertex. It's just that this is like +0 then. So the vertex would be at 0, 5. You still take these two numbers. If there's no number there, then there's a 0 there. Okay, now you have a Schoology quiz and a lot of time to work on it. So I strongly encourage you to work with the kids next to you. If you do have individual questions about your homework, cool. It could be about your cumulative on your desk, cool. It could be about old stuff like, can I start doing corrections on my old test? Sure, just gotta ask me. That's all I have for the video.